Hi, everyone. I'm Ben. I'm very clumsy. Just knocked over a beverage on my way up here. Thanks for attending my session. Thanks for the introduction, Randy. I am indeed here to talk about architectures and not to talk about products or anything like that. Particularly, I want to talk about the idea of depth in systems and what the implications of depth, and specifically how we can think about that in the context of a couple of problems that I've been working on for a long time, just because those are the ones I'm most familiar with. So the talk is divided into three parts. The first part is about scaling in general and deep systems. We often talk about scale when we're at conferences or at our jobs, and we refer to it as if it's a linear concept and a one-dimensional thing. I think if any of us were asked, is scaling linear or one-dimensional, of course we'd say no, but we still keep on doing it. So I'm trying to find a better word to describe the type of scaling that I think is really problematic architecturally. So one type of scaling is scaling wide or scaling broadly. So here's a puddle. We're all familiar with those. A puddle is a bunch of water on the ground. If you add more water, you get a really big puddle. And if you add even more water, you get a really, really big puddle. And so this is an example of something that scales wide. There are many of them in the world, and I'll let you think about it, but it won't be hard to come up with examples. Sand dunes, satellite arrays, things like solar panel arrays, things like that. There's also a different type of scaling that I would call scaling deep. So here's a small village. It's a place where some people live, hopefully, semi-permanently. If we scale up a village by adding more people, it starts to look more like this, which is a medium-sized city. And if you add more people and find places for them to live, it looks more like this. And this is an example of something scaling deep. So in this case, the thing I want to emphasize is that the deep system, in this case the deep city, is not just a large village. It's a different thing altogether. So when things scale deep, they change fundamentally, and we probably need to have totally different infrastructure to support them. Certainly the infrastructure to support a village would not work to support a city like this. If you've ever been to Paris, my favorite thing in Paris, aside from the food, is the sewer museum, where you can go into an old Parisian sewer and actually experience the engineering marvel that is the Parisian sewer system. I mean, the entire city was literally grinding to a halt from like cholera and diphtheria and all sorts of horrible things that happen when you don't have good sewers. And then they fixed the infrastructure, and then it actually allowed the city to scale literally from a population standpoint. It's really fascinating. But moving beyond sewers, there's also things like hardware. This is an example of a deep system in hardware. I think even just visually, you can look at this and be like, that looks really complicated, and it's not just like a lake of silicon. Like, this is really complex and has a lot of nuance and depth. So the question is, what does it look like for software, especially software built around services? The microservices and serverless movements are really based on a managerial need to have small groups of engineers and developers operate independently. If you have thousands of engineers, then you have hundreds of services, and you have to arrange them. So when we started Lightstep, I actually asked myself that question, since it was important for our product. What would it look like if you have, I saw what it was like at Google. I was at Google for about 9 years, and I know how their system was built, but how does it look for the average microservice architecture? Is it going to look like this? So this is an artificial system diagram of software scaling wide architecturally. So each of those circles in my mind is a service. There are examples of this sort of behavior. For instance, like cache services, map reduces, things like that do have aspects that scale wide. So it's not like it's unseen in the realm of software. But I would say for microservices, it's the exception to the rule. There's also software that scales deep. This is a diagram based entirely on my own dragging and dropping of little circles in a slide, so you shouldn't take it very seriously, but this is what software might look like if it's scaled deep. But we can actually ask ourselves the question, what do real software systems look like? Interesting question, right? I present to you some totally blurry, intentionally anonymized diagrams of real architectures, just so we can have some grounding. These are chosen at random from a bunch of architectures that we can where we have data for this at my company, which is irrelevant to the pitch, but just let's just think about it. So this is about a dozen or so services. There's actually two distinct sets. It turns out one, I think, has to do with producing like ML type models, and the other serves them. So you have like an indexing pipeline, a surfing pipeline. This is more like 50-ish services. This is more like 100 services, but I couldn't fit it on the screen. This is more like 1,000 services, and I really couldn't fit it on the screen. This thing goes like way out to the next building. It's just crazy. And the answer is that microservices at scale are deep systems. I feel really confident about this, having worked with a lot of folks and thought about this for a long time. I'm absolutely positive about this. And by deep system, I mean that the architectures have greater than or equal to 4 layers of independently operated services. Some of those will be in-house. Some of them will be managed services in the cloud, whether they be like just literally a managed open source service like a managed Kafka instance, or if it's like totally proprietary stuff like Cloud Spanner or DynamoDB or whatever. These are all, they're independently operated services, and with each layer of the service architecture, you introduce a new opportunity for miscommunication, multi-tenancy, unexpected releases and unexpected side effects of those releases. These layers are really the thing that produce problems for operators and developers in these systems. And so what does that sound like? So it might sound like this. This is kind of a classic thing debated on Twitter. That is a great indicator of a deep system. This is another one. Where's Chris? Things are totally on fire. He or she is the only person who actually knows how to debug this problem. I think people here probably can resonate with that. I certainly have been there as a person looking for Chris, not unfortunately as the Chris. It can't be our fault. Our dashboard says we're healthy. So I saw this all the time at Google. It's like you've got 2 services. There's definitely a problem. Everyone's agreed on that. The consumer says, oh, it's a service. And then the service says, no, it's a consumer. That's something in the client. Sometimes it's the network, and they're both right. But this is a huge problem and produces a lot of friction in an on-call cycle, but also reduces trust within organizations. Like, this is the kind of thing that people don't forget, and like it's bad to have relationships within work where you don't trust people. Kafka's on fire, also something everyone here is probably quite familiar with. This is usually a symptom of multi-tenancy. It's not really Kafka's fault. It's tough if you had this great idea. The platform team is going to run one giant Kafka instance for our entire organization, which does make sense. But it turns out that a single bad actor can run rampant in that Kafka instance, and that has a lot of unintended consequences. So this is another symptom of a deep system. This is a real story for myself. I worked on Google Monarch, which is Google's high availability time series system. I think they've since publicly talked about it, and they've quoted that it's running on 200,000 VMs all the time. It's a giant system. And I was in a review with a SVP at Google, and he said he needed 100% availability from Monarch, which I thought was a preposterous statement because that doesn't exist. As I said, well, how many 9s do you actually need? And he just was like 100%. And to me, this is evidence of politics. So politics are often a part of deep systems where he, of course, wasn't responsible for budgeting Monarch, so he could ask for ridiculous things like 100% availability, which doesn't make any sense to anybody, including him, I think, but he didn't care, right? So it's like politics are a symptom. Oftentimes you don't know you depended on something, and then it goes down and you do realize you depended on it, but this is the downside of abstraction. We create abstraction, and then we forget that no one knows what's underneath abstraction anymore. This happens all the time. Like, you knew that you've seen a dashboard, and you're in your mind's eye, you can remember seeing the dashboard you wanted, but you can't find it, and you can't like string search for it, and so it's basically not useful. Anyway, the themes here are a lot of people management issues, security issues, multi-tenancy, Kafka stuff. I would specifically talk about big customers. We've seen this a lot in our travels at Lightstep, that you have you have a pretty reliable, available system with decent latency, and you have like 100,000 customers, but 5 of those customers generate 70% of your revenue and 70% of your workload, and those customers end up having a very bad experience, despite the fact that the average or even the P99 metrics look pretty good. This is another form of deep systems and multi-tenancy causing trouble. and performance, and then finally observability. I put that one in blue, mainly because I actually have more to say about that than other topics, just because I've just spent too long thinking about it. So we'll focus a little bit more on observability in the rest of this talk, but I really want to make sure people understand this basic concept of deep systems and what that does to all of these different aspects of running a business and having an application. So hopefully that part's clear. Okay, so part 2. Control theory. So this is not my area of expertise, to be clear, but I'm going to try and step way back. Observability is such a long word. I think it's 6 syllables. I can't count. It's too many. But it really comes back to control theory I think in the 60s. Why do we care about observability? It's an awfully long word. It definitely gets there's a lot of people talking about it, but why is it important? It sounds very passive to me. It actually sounds like observability. It's like you're looking at the system through this like pane of glass, and it's this blurry thing on the other side, and it feels very disempowered to me as a word. But we must care about it for some reason. So let's go back to the definition. So control theory, you have this idea of a system. The system has a state vector, which mathematically is just an internal implementation detail of everything happening in that system. It has a number of inputs where operators can control the inputs to the system, although they can't directly control the state vector, and then a number of outputs. Observability is concerned with the outputs and the state vectors. So it's saying observability is a measure of how well you can infer the internal state just using the outputs. So you don't get to cheat. You can't actually look at the internal state unless you make the internal state an output of some sort. So you just get to look at the outputs. You have to figure out what's going on inside. And that's the reason why I think people have used that term a lot lately, is that it's pretty rare to be able to run a real honest-to-goodness debugger like GDB or something like that. It's really hard to run something like that in production these days for a variety of reasons. So all we've got are the outputs, which in modern days are basically the telemetry. So you have the telemetry, you have to infer the state of the system. Controllability, on the other hand, is very similar. So you have the inputs, and the question is, just by controlling the inputs, how well can you manipulate the state of the system, the internal state of the system? So that's controllability. And in control theory, controllability was the thing that everyone was talking about, and observability was like this little sideshow, and it wasn't the point. I actually kind of wish it was that we could get our industry back over to the controllability side of things, because that's really the one that matters. Like having control of your system is a very empowered position to be in. And so why do we talk so much about observability? There are a number of reasons for that, but the most important one is that mathematically, controllability and observability are duals, which means that, colloquially, if you make a change to improve one, you're also probably making a change to improve the other. To me, this is like this profound thing where it's like, whoa, this is really deep. I find that very distracting, so I've created okay, there you go. That's less distracting. So the point here is that if you make a change to improve one, you're probably improving the other. A good example of this would be the craze around service mesh. I don't think people necessarily are thinking this to themselves, but my gut feeling is the reason it's so exciting is we instinctually realize that we're getting both. Like service mesh gives you a single point of control for the internal state, i.e. the RPCs in your system, and it also gives you a single point to observe the telemetry. And that's a very appealing thing. A lot of changes that we make in one place are effective in the other as well. So these two things are closely linked. And that brings us to part 3. So what do deep systems mean for observability and for controllability as well? So here's a simple diagram. So on the sort of horizontal axis, we're looking at the total number of services. On the vertical axis, there's the number of developers per service. So the transformation in our industry right now is really going from pure monoliths, where you have basically one service with a lot of developers, and then you kind of quickly try to spread that out into smaller services around that, and then you develop layers beneath it. And somewhere in the midst of that transformation, you have a deep system once you get 4 or more layers, and you're confronted with all the sorts of problems that we were talking about earlier. So this is the overall arc in our industry. If we want to think about why this is so painful, it's probably easiest to talk about stress. So stress can be defined as responsibility without control. So if you are in a deep system, and let's say you're responsible for the service at the top of that triangle, very literally, the only thing you can control is your own service. So from a controllability standpoint, that is what you control. But if anything beneath you is having a bad day, you are actually responsible for that, and that it bubbles up to you. So the relationship between what you control and what you are responsible for as your system gets deep is completely out of hand. I want to emphasize that the thing at the top is a dot, and the thing on the bottom is actually an area. I'm going to do some pseudoscience in just another slide or two, and that we have to think about that area when we're doing it. So here's the pseudoscience. My contention is that as your system gets deeper, you don't really get to control anything more than the service you started with, but your scope of responsibility is actually proportional to the square of the depth of your system. And this is why things get so totally out of hand once you're in a deep system if you're using conventional tools. And everything about observability is about tightening that gap, both by giving you more leverage and more control, so bending that bottom curve up, and by helping you cut through what you're responsible for as quickly as possible so that you don't feel like you have to do a linear search through it, because that is not going to work anymore. So this is how I think of deep systems affecting observability conceptually. We started with this super abstract thing. We also have this way too concrete thing. In the middle, I'm going to sort of use this pyramid structure for the remainder of this discussion, just to help ground this in something that's a little bit more concrete, but not too concrete. So managing these systems. This is something I feel really strongly about. This guy, Alex Hidalgo, is writing a book about SLOs, which I'm about to talk a lot about, and I would encourage people to read that. But this is like my one-slide version of that book, basically. So if you want to manage deep systems, I think you can model almost everything in terms of service level objectives. So typically, not always, but typically SLOs are objectives around latency, errors, and throughput. Sometimes there's some other things that sneak in there, but that's the lion's share of them. And the idea is that if you want to understand the relationships between these services, the best way to do it is to think about what your consumer needs. So you should always be thinking, if you're a service owner, what does my consumer actually care about? Those are what you structure your objectives around, and everything you do should be about, basically one of three things. The first one is obvious. It's releasing new service functionality. So we're all, hopefully, for developers, at some level responsible for pushing new functionality. If it wasn't for that, the easiest way to maintain your SLOs would be just to walk away from the keyboard and never push another change, right? So we do need to do this. It's number 0. The other two things we need to do are to gradually improve our SLOs. So that looks like this. Like this quarter, I have an OKR to improve my P99 performance by X milliseconds. Something like that, or I want to reduce my error budget even tighter, so our consumers see fewer 500s, that sort of thing. The other thing you need to do with SLOs is to rapidly restore them. So this is basically to say at 2 in the morning, you can get woken up, and you have to get your SLO back into compliance as quickly as possible. Typically, this involves rolling something back, although unfortunately, it's often not your service that needs to be rolled back, so something downstream or upstream can change, and that can affect our SLOs. But I think it's really important to focus on SLOs because they both make this problem feel less overwhelming. I think the total number of things happening, if we're talking about that diagram with the internal state of a deep system is literally too much for a human being to comprehend. So we need something that's a little bit more manageable. It's also conveniently the thing our consumers care about. So SLOs, super, super important. And in a deep system, we have to control the entire triangle below us in order to maintain our SLOs. If we're not able to account for and react to the things we depend on, we will not be able to have control over SLOs, and thus, will disappoint our bosses and our consumers and everyone else, and it's a bad day. So this is what it's all about. I spent a long time in this slide just to make sure it sunk in. I hope this makes sense to people. Cool. See them nodding heads. So there's that word again. So control, controllability, observability. These things are all very tightly coupled. The conventional wisdom about observability is that it's difficult, that Google and Facebook solved this. P.S. they did not. And that they use metrics, logging, and tracing, so we should too. I mean, obviously, I'm putting this up as a straw man. This doesn't make any sense. It's like illogical argument, just a literal level, and it's also wrong, which I'll try and explain. So 3 pillars, 3 experiences. So that's one way of thinking about it. This is often referred to as the 3 pillars. You have a whole lot of metrics that come out of your services. You have a whole lot of logs. And maybe if you're kind of into the new stuff, you also have some traces. And you develop a product strategy or an observability strategy around 3 products, or at least 3 different SKUs that you buy separately. And then from a workflow standpoint, you need to go back and either improve your SLOs or resolve them quickly using these 3 different products. This is really crazy making for me. This is absolutely not a pitch for any particular vendor, but I think this is a terrible way to think about observability. And it's not an honest representation of how things work at Google. I can't really speak for Facebook. We did have some of these things, but I would say very frankly that what we had at Google for observability was pretty bad. I mean, all things considered, at least when I left in 2012. It was better than, what other people had at the time, but we spent a lot of time like struggling to understand our own deep system and didn't really have the right technology to do it. So this is nothing to mimic, I guess is what I'm trying to say. I think it's upside down, in fact. So let's think about a different way of modeling this. So let's talk about 2 giant pipes of data. So I definitely think all that stuff you saw is super, super important. I'm not good enough with this to go back to the slide, but we are talking about observability being based on the outputs. Those are the 3 fundamental outputs. It's the telemetry. So they're the 3 pillars of telemetry, not the 3 pillars of observability. You can think of each pillar of telemetry as a pipe. One pipe are a bunch of metrics. Another pipe are a bunch of logs. And then if you don't have any traces, the cognitive load of understanding anything below you is basically tantamount to doing a linear search through metrics and logs and dashboards around those metrics and logs. And if I haven't made it clear enough, as your system depth increases, what's underneath you may be dozens or hundreds of services. So that's just not really, it's fundamentally infeasible, I think, for a human being to do that kind of information retrieval exercise. It's too much to take on. So the answer is to sprinkle traces on it, which doesn't make any sense either. So if there's maybe one thing you come away from this talk, it would be that deep systems are a thing. The second thing is that traces are not sprinkles. If you put traces on top of everything else, it will solve some problems, but they're not very interesting problems. They're just like, you'll be able to look at individual transactions, but the more important task is trying to reduce the cognitive overhead of everything else that you're dealing with. So you have too many metrics and too many logs. How can we use traces in some fundamentally new way to reduce the overhead of the metrics and logs? So I'll focus in on this this piece. So the idea with traces, I think everyone here gets the basic pitch, but they're just, it's really like fancy logging. You have a transaction log that goes all the way through your stack and follows individual requests as they propagate from service to service. So by their very nature, they span the entirety of your architecture, or at least they should. One aside here is that at Google, we had a little bit of a leg up in that we were able to trace through our storage layer. For most people who are sane anyway, you don't try to write your own storage layer from scratch and you depend on someone else, like a cloud provider or a database or something like that. I would love to see the cloud providers find some way to share a little bit more about what's happening within their managed services with their consumers. That would allow us to understand our dependencies, or at least understand why our queries are slow without just sort of like grasping at straws or filing support tickets. But anyway, you get traces. They go through a lot of your system, and they provide context. So in this case, we have a dependency on a particular service that's slow or having errors or what have you. The important thing is not that, but everything else. What the traces can allow you to do is to eliminate everything else as interesting. So you can rule out any hypothesis that's not having to do with that particular dependency chain. And in this particular diagram, what is it? I can't count 7 services, but imagine that there are 50 or 100 or 1,000 services. This is a much bigger win. You're basically taking a geometric problem and making it linear in terms of how far you need to look. And the most valuable thing that traces can do is not to explain what happened, but to explain what did not happen. That's what we should be using them for. And then if we kind of go back to this diagram, the point of traces should be to provide a filter, use the context from traces to provide a filter, and reduce our consideration. I don't want to make it sound like traces are going to solve your problems. They're not. What they will allow you to do is to focus on the subset of your telemetry that actually is related to your problems. And this is a pretty powerful difference in a deep system. I hope that makes sense to people. By the way, no one has done this yet. Like, I think we have a lot of people who are pecking away at it, but this is where I think things are going, and I think where we should be headed and the way we should think about these problems. And you can get a glimpse of it in certain places, but this is kind of aspirational in my mind. The point of traces is that they can reduce your cognitive load from the square of the depth of your system to something closer to the depth of your system. A deep system is always going to be harder than the shallow system to understand, but hopefully it's not so much harder that we're in paralysis. So the idea is that observability will be able to shrink this gap between the scope of our responsibility and the scope of our control. And traces can provide something pretty fundamental. They can provide the backbone for some sort of much more rigorous and automated process of observing and understanding our systems. So I may have made a mistake by doing this, but I've intentionally I've tried to leave like extra time for questions and so on and so forth. I'm going to go through what I've talked about so far. We're going to have plenty of time for like an actual discussion or questions. But let me just summarize what we've talked about so far. So microservices, they don't just scale wide, they scale deep. And we have to recognize when we're in a deep system. The stress of operating a system is that you have far more responsibility than you have control, and we need to find some way to minimize that. The controllability of your SLOs, it depends on high quality observability. You can't divorce the two from each other. They're very tightly related. The 3 pillars of observability is a terrible metaphor, and traces are not sprinkles. So traces need to be more like the backbone because they can reduce cognitive load from the square of the depth to just the depth of your system. As I said, tracing should be the backbone for simple observability in deep systems. And I think with that, if Randy's not too upset with me, I actually am pretty much done with my talk. I'm definitely not here to talk about my product. You can play with it just because it touches on some of this stuff, and you can also provide any kind of feedback. But with that, I'm hopeful that some people will stick around. We can have some Q&A, and especially, or even if someone wants to grab the mic and just say whether or not this resonates with their system, I'm really interested to get some conversation going too. Thanks. Great.
So I'll run around with this mic. If you want to raise your hand to ask a question, great.
All what I got from the entire conversation is the traceability part. When I architect or when I design something, I do think about traceability, telemetry, and how my microservice will get into the deeper. But apart from the traceability, is there any pattern which the architect has to follow so that the best way it can be implemented in depth? Do you suggest any way of approaching the architecture itself, taking traceability?
Yeah, that's a great question. So, I mean, I think the most important thing for architecting around depth is probably some sort of rigorous standardization of the way that services are deployed and operated. I think things like SLOs from a managerial standpoint are incredibly important. I would also say that it's not like your entire system has to use one language, but allowing a total proliferation of like 12 different languages or something like that makes it really difficult to create a common it makes it extremely difficult to have any leverage at the platform level. Like you can't have a security team roll out a fleet-wide thing that sits at the application layer if you have too many different languages. For instance, I think service mesh again is very helpful for this. But it's like trying to have the platform team create a paved path. I think is the most important single thing for ensuring controllability and observability.
So you had your 3 pillars was metrics, logs, and traces. I don't really know what you mean by trace. Can you define trace and how it compares to metrics versus logs?
Yeah, sure. So, right. So I think we're talking about this. So I have like a rant that I haven't written down yet about logging and tracing basically being the same thing. I was talking to a customer and he was saying that he thinks of logging as selfish tracing, where the idea is that logging is about your own service, but the logs that you're creating are difficult for other people to understand or consume because they're not connected to transactions. The only difference between tracing and logging fundamentally is that traces keep track of where the request came from. So you can stitch together a single, like a correlation ID in a logging system, like if you use Splunk or something like that, a correlation ID is often a way of getting a version of tracing going with a logging system. The reason why tracing ends up being its own category of things is that the task of propagating the context along is very difficult, and so it required like a bunch of additional work in the open source world. So like open tracing, open census, open telemetry are all tasked with that. And then also tracing generates so much data that no one has figured out for a high throughput production system, no one has figured out how to get all that data recorded durably for a long time. And so tracing often immediately introduces new problems, like how do you deal with sampling, how do you deal with summarization, that sort of stuff. So tracing is like logging, but for entire transactions and at a level of detail where you can't afford to store all the data. But they're very similar conceptually. It's just that those engineering constraints forced a new set of solutions. And so that's how we ended up with a new term, I think.
You mentioned microservices and service mesh. How does any of this change, if at all, with eventually consistent, event-driven, event-sourced systems?
That's a really good question. I really like the idea of things being eventually consistent and event-driven and so on and so forth. I think that the appeal of the systems that precede those sorts of event-driven, eventually consistent things is their simplicity in terms of understanding. Like it's not difficult forensically to figure out what happened if you have a trace, whereas for these eventually consistent systems, that's like a fancy way of saying in some ways that it's going to be really hard to look at a single transaction and understand everything that happened. So the fact that interference between transactions becomes like more of the norm in eventually consistent systems, I think presents a lot of diagnostic problems, both from a correctness standpoint and when there is a choke point or some kind of concurrency issue. I think also those can be very difficult to diagnose. The Kafka is on fire thing, I know Kafka is not a perfect example, but that's the sort of thing I'm talking about. Those sorts of problems where no one actor is necessarily doing anything wrong, but the sum total like puts something over a scaling limit. It's just so nasty. And in those types of architectures, I think it's easier to get into that kind of pickle. A lot of the best, in the sense of being the most senior and decorated engineers at Google, certainly much smarter than I am, they would churn out these very simple designs that were really, it seemed like a design constraint was just debuggability because it was so hard to understand what was happening. And they would, like Jeff Dean has a great talk he gave at Berkeley many years ago about how the way that he was recommending to deal with tail latency was just to make 2 requests for every one. Just literally make multiple requests and take the one that comes back first. It's like so gross, like you're literally halving the efficiency of your system from a dollar standpoint in order to deal with this tail latency issue. But those sorts of inelegant things can often be very usable. I don't know if that answered your question. But.
Other hands for questions? Yeah.
I also, if anyone wants to, before you go, can I just have a show of hands? Of the people in this room, how many people think that their company or their business unit is operating like a deep system, per my definition? I'm just curious. Okay. All right, that's reassuring. Thanks. Go ahead, sorry.
My question is, what if in my microservice cluster, I already have all the metrics, logs, traces system set up? So what's the life looks like after I have everything set up? What kind of experience do you have to share after I have metrics, logs, traces set up?
I mean, as I think I was saying this towards a few minutes ago, a lot of this in my mind is a little bit aspirational. That is to say that I don't know of a way to have everything work perfectly right now. I think the biggest hurdle is actually the telemetry. It's less about the solutions themselves, but just the quality of the data that we're getting out of our systems is so poor that, going back to the theoretical slide, oh my God, too many slides. What was I doing? Yeah, going back to this, the quality of the outputs that we have right now is very, very low. I think open telemetry is, I'm totally biased, but there's a lot of other folks involved with that project. I think it has a lot of promise in that the trouble with a lot of the previous efforts was that although the idea of it made a lot of sense, it required developers to go and do a lot of manual work. And I think most developers aren't getting paid to instrument code, so they don't really want to do that. And so you end up with low quality telemetry from most of your system. Open telemetry does have an effort now to automatically install itself in a process. So just by turning it on, you'll be able to get a pretty high quality telemetry stream out. But until that happens, until the outputs are there, none of the stuff is going to work that well. And so I think the most important thing as an industry is for people to push for higher quality telemetry, which the main thing that's missing actually is tracing, but I think there's also pretty low quality metric instrumentation where you have huge cardinality problems, stuff like that. Getting higher quality telemetry would be enough to unlock a lot of value, I think, in a number of different approaches. And then the other piece of it is to design around use cases. I think a lot of observability tooling right now is built around these data types, which is sort of stupid. The telemetry is important to the tool, but it should not be important to the user. The user is generally trying to resolve an incident, or they're trying to do a release or whatever. And the use cases for observability should be built around those actual real-world scenarios, not around a database, a database query interface for these underlying telemetry data types. And I think that transition is starting to happen, but it's a very painful thing to do, especially in open source, because the various pillars, so to speak, have been built as separate databases that don't naturally integrate. So I think a lot of the work, if we're talking about open source solutions, a lot of the work has to do with reimagining these workflows around use cases. And for vendors, it's a little bit easier, but you have to pay for those. So, yeah.
Basically, optimize everything you have, make the life easier for debugging.
Yeah, and I would encourage people to evaluate observability based on use cases. I think it's really silly to say, well, do I have traces, metrics, and logs, or do I have this, this particular data type? It's much more interesting to say, I'm doing a release. What do I want to have on the screen while I do a release to guarantee that I have confidence even at 4 p.m. on a Friday? That's the sort of thing that we need to be asking ourselves when we're evaluating tools, rather than does it have this particular data type in it.
Thank you.
Yeah.
As a developer, how would you introduce SLOs in your company and to other teams and try and get everybody on board with that?
That's a really good question, too. I think that it's easier to motivate people to establish SLOs if they have some kind of, if they get something for it. One way to do that, depending on your organization, sometimes management actually has the respect of the engineering organization, so they can just say, we were doing this, and then that's the easy case. When that doesn't happen, I think it's also feasible to say, to your, if you're a service in the middle of the stack, or even if you're at the top of the stack, there's like a mobile or web app that depends on you, just to say to them, I'm going to establish an informal contract with you that like I'm going to do these things and get to this level of performance, and then I'm going to stop. I think the point of an SLO is that you're giving yourself permission to stop at some point. You're saying, well, I'm within my error budget, so I'm not going to actually prioritize greater reliability, even though you had an outage last week, like I'm still within my budget. And so it gives you the permission it gives you the capability to make more, you can predict your velocity better than if you're just reacting to people, the loudest, squeakiest wheel above you, if that makes sense. So I think SLOs are a good way to establish expectations. Yeah. There's a question at the back, I think, not to run all the way to the back. But.
It's my mission to get as far as possible and then make Randy run to the corner of the room. I had two questions, actually. I think this whole thing is super fascinating. So first, because you talked a little bit about control theory and introduced control here, I'm curious, like often in other systems, the next thing that would come in would be feedback and actually using that feedback to generate that control, right? But it seems, certainly in my organization, it sounds like what you're talking about. You're creating context and observability so that we can go debug problems as opposed to actually responding, right? I think we have simple examples like auto-scaling groups, and after that, it's like humans. So I'm curious if you have any examples or cases of where feedback has then been used to actually create that automated control mechanism. And then the second question, which I'll ask so I can give Randy the mic back, is you talked about the overlap of logs and tracing. I actually find the overlap of logging and metrics very interesting. There's a lot of opinions out there, and I think people are using them differently in different organizations. So I'm curious if either you have a strong opinion on how you separate them or if you see some convergence there. Thanks.
Cool, that's a good question. Both are good questions. So in terms of feedback loops, yeah, that's really tricky. I mean, I think that's the most interesting thing that I can think of to refer back to Google. I think they've written about this, so I don't feel like it's a problem to talk about it. They have these really large multi-tenant storage systems, right? So Bigtable, Spanner, whatever. And they spend, I don't know how much money, but a lot of money. Many AdWords clicks are spent on their storage systems every second. And so they naturally want to optimize their usage. It's probably not dissimilar to any of you. It's like you have a database, it's expensive, you want to make sure you use all your capacity. The trouble is that if you have some big storage system and it's multi-tenant, in order to maximize your efficiency, you want to make sure that it's the Kafka's burning scenario all over again. You want to ensure that a single bad user, because at Google there are about 2,000 different product lines. A single product line shouldn't be able to blow up the entire shared resource. So what they did was Dapper was, which I helped to develop, was Google's tracing system. First of all, going back to the controllability thing, Dapper was actually a hack on a controllability thing. So there's something called control flow at Google, which was the way that we propagated context for totally different purposes. And Dapper was only possible because that already existed. It was a way to control the behavior of applications. We piggybacked on that and made a tracing system out of it. And then we kind of went back the other direction and took the Dapper trace context and just stuck one ID in it. And the ID was, what product did you start with? So if your request came, not like at the bottom of the stack, you had no idea, but at the top of the stack, if it was Gmail or web search or whatever, there was a unique ID for Gmail and web search and calendar and all the rest of them. And you kept that unique ID literally like in a thread local all the way down the stack into the kernel, basically, where it was actually doing disk I/O. And then, this is the feedback loop piece, we would aggregate all that information. So if you were doing disk writes or something, you could say, I want to guarantee I only have 1,000 units of disk writes for this entire region. I want to allocate 7.5% to Gmail and 2.8% to calendar or whatever. And it would, in real time, aggregate all the disk writes and then push back if someone went over their quota. So we were able to run massively distributed multi-tenant databases with lots of different clients. And the second you went over your quota, even though you as Gmail were way at the top of the stack and your identity had otherwise been lost throughout the architecture, we were able to enforce that, which probably saved Google hundreds of millions of dollars a year. I mean, I'm making that up, but it's certainly more than that. And that's a great example of taking an observability tool, which was the trace context, throwing one little integer into it, and using that to do resource accounting and enforcement across the entire architecture. And I think a lot of organizations would benefit from that, similarly from an economic standpoint. And then your second question was logging in metrics. I hate the term metrics. I didn't say that because I felt like I was already ranting enough, but it doesn't make any sense. A metric is just a statistic over time. That's all it is. And yeah, totally. It's like you can count the number of times you log something and that becomes a metric. I don't know why it gets to be a metric if it's like emitted by the process. It doesn't make any sense. The only metrics that are really true metrics are things like gauges, like CPU load, memory usage, things like that aren't counters. But when you're counting events, which is almost all metrics, I agree it's just a matter of when do you do the counting. If you do it within the process, we call it a metric. If you do it like in the SaaS logging tool, we call it a query. It's just BS. It doesn't make any sense. So yeah, I kind of agree with you. It's very fuzzy. There's another question up here, I think.
So I was thinking back to the question earlier about event-driven architectures, and it kind of occurs to me that maybe what you're doing when you have an event-driven architecture is you're breaking the synchronous immediate consistency boundary between services. And so in the context of this talk, it seems like what you're doing is basically reducing the depth of your system by letting your service handle its own local cache building, essentially, of downstream services as a separate process. So I guess my question to start with is, do you agree with that? And if so, do you think there's a certain level of depth, knowing that that's sort of a lever you can pull to control your depth, where this sort of more advanced observability becomes necessary or not?
That's a really good question. I don't think I have a prepared response for that one. Yeah, I mean, I hadn't thought about the caching piece of it either. I'm not sure. I don't like BSing people, so I'm not going to make up an answer on the spot, but that's a good question. And if you come up afterwards, I'll try and talk to you about it, but I don't want to make something up and be wrong or hate myself watching the video later. It's like maybe time for one or two more questions.
Sorry, this is a little different. So we are in the agile world, and what management does is just, we need to do this. So this team, 7 people everywhere, right? And they're mostly working on features, right? So these are cross-cutting concerns, right? And not each one of them may be aware that they need to be aware of all this. So how can you go back to management and say, I need a complete new team which just does DevOps? You know, in the name of DevOps, they just give you 2 or 3 people, right? They sometimes throw in some jargons, throw in Kubernetes, Rancher, something like that, right? And fundamentally, as a software engineer, yes, I am aware that we all have to log beautiful logs, you know, well-written English, which everyone understands, or any other language, right? So my question to you is, how do I go back to management and say, okay, Agile is fine and dandy, fine, you are transforming us, right? How do I make sure these kind of problems are solved by an Agile team? Can I say, give me an Agile team which just does this?
That's a great question and one I think about a lot. My opinion, and you should try this and then send me an email and tell me why it didn't work, but like my opinion is that the best answer would be to find a pocket of within your organization where you have a direct consumer and producer relationship between 2 services where they're having a hard time agreeing about what's going on. That thing I said about how this sounds when you can't get agreement about 2 teams that are talking about the same thing, find that little pocket, have both of them adopt something that's not, if not best practices, at least good practices, show how it resolved the issue, and bring that as like a mini case study to management. The answer is definitely not asking management to go and implement this across the entire system. That will never work. But I think you can create a little pocket of excellence. The nice thing about those triangles is that they nest. So you can just find a triangle with 3 nodes on it, or 2 nodes, frankly, and show a lot of the value here as like a mini case study, and then try to build out from there. So that's the way I'd approach it, I think. I think that actually does work. I don't know, Randy, if I have time or not in this.
One very quick question. Asked quickly, answered quickly.
The answer is yes.
Maybe. So this seems an awful lot like automating the Deming circle. in a lot of ways. And so from the standpoint of selling it to management, does that end up working for this sort of thing if they're familiar with that? Because I mean, it really seems to relate quite well to that.
You should try that too and let us know how it goes. I'm not sure, that's a great question, but I'm getting a sign to stop. I see a big stop sign. I'll talk to you later. Thanks a lot, everyone.